All right, election year this year. How many times do you see on television, recent polls say Obama's going to get this percentage, Romney's going to get this percentage. And at the bottom they say with a margin of error, a sampling error of. How in the world can they know that? How do they know the election hasn't even happened yet? Not only what they think the final answer is going to be, but then how far off they think they are. It's all based on your knowledge of what a sampling distribution is. I mean, they had stuff like, okay, Obama's going to get 51%, and down here they wrote something like with a margin of error of plus or minus 3%. What that means is they're telling you that the final results are going to be somewhere, take 51% and minus 3%, 48% to 54%. They're saying they're sure, or really, really sure, that the final answer is going to be in that percentage. I mean, they asked like 1,000 people of the 50 million that voted. Yet they're sure, or pretty darn sure, it's going to be coming within that percentage. How? It's this. Now let's go back to this thing called the sampling distribution. Now we've talked about different criteria that we have to have all of these numbers come into a normal distribution. But let's think about this for a second. If this data can be closely approximated by a normal curve, don't I know, go to empirical rule, don't I know that 68% of these are for sure within one standard deviation, and 95% of these are within 2 standard deviations of the mean? Isn't that what we know? So I know I'm only getting one of these, right? I'm going on television with one of these. But don't I, before I start, know I've got a 95% chance? 95% of these, if I go 2 standard deviations out from on both sides of whatever I get, won't that capture the real mean? Aren't I within 2 standard deviations of the mean 95% of these? That's how they know. They know before you start how bunched up these guys are. Let me show you that in terms of a picture. I think the real mean length of names was around 12.9. Okay, that was the real, actually, take all these names and calculate the mean length of them. So we know that 95% of those blue guys are in this range. So this is what they define as this thing called the margin of error. Now notice how this works. Let's say your X bar was here. Maybe your X bar was a little bit more, 13 point something or whatever. You're right here. If I go this distance this way and this distance this way, will I then capture, will the true mean be somewhere in this interval? Absolutely. In fact, 95% of those. Let's say I was below the mean, but I was right here. I go that distance this way, that distance this way, and after I look at my interval, the real mean is going to be in there. But are you guaranteed that your interval will capture the true mean? Poor Sean Hop. Right? He did everything right. He took a good sample. He just happened to get a crazy sample. There was only there's 95% here, it's only about a 5% chance you could get a crazy one like that. But he did. And notice, if we go that distance both ways, will he now capture 12.9? Is he going to be able to capture 12.9? No. That's what a confidence interval is. You start from your point estimate, knowing ahead of time there's a 95% chance you're going to be in here someplace. That means when I create my interval, okay, I got a great chance of capturing the real mean in there. A lot of good questions earlier. Any questions in your mind? But tomorrow we're going to do this math and figure out what this distance is. Figure out how we calculate that. But just conceptually, Had somebody third period say, well, let's just be 99.7% sure, right? Wouldn't I go 3 standard deviations out? And that way I'll sure that I've got the right answer in there? Yeah. There are 99% confidence intervals, 98% confidence intervals. 99.7%, I go 3 standard deviations out. Unfortunately, what happens if you want to be that sure is you'll get something like, hey, Obama's going to get 51% of the vote, plus or minus 20%. 31% to 71. Hey, gee, thanks for that. So it's a little bit of a balancing act. How sure you want to be. This is something they never tell us, how sure they were. When you see these confidence intervals, they never actually tell you what confidence interval they use. 95% is kind of an industry standard. All right, so this is a big, giant sentence. You're going to write it about 800 times between now and May 10th. When you do your confidence intervals, you're going to learn how to do them tomorrow, and we write the conclusion. This is going to be the first sentence that we write. Now take a step back, breathe it in. Does this make sense to you? Before selecting my samples, and all of you, before you reached in here and you grabbed 20 of these things, you know that when you find your X bar, you're going to have a 95% chance of being within 2 standard deviations of the mean, right? Before selecting a sample, 95%, that's called the confidence level, 95% of all of the sample means of size 20 will create a confidence interval that captures the true mean. 95% of those blue guys! If I then go create a confidence interval, it's going to capture the right answer. That's what that sentence says. That's the method we're using. Now everything underlined can change depending on how I asked you the question. So for this particular one, before selecting a sample, 95% of all the sample means of size 20 will create a confidence interval that captures the true mean length of names for students at Elk Grove High School. So the underlined part will change depending on what kind of problem you're doing. Yeah.
Just to make sure, the mean of the sample you get, the red line through it is just the confidence interval you have, and then if the confidence interval is close to like how the first one on the first top one, it's encompasses the true mean, and that means it's pretty accurate.
Yeah, you even say close, so the question is, as long as I get an X bar that's close, and then I create my interval, I'll capture the true mean. Is that the question?
Yeah.
Yeah, close, but as long as it's anywhere in here. If I get an X bar that's right here, okay, well, when I go that distance, I'm going to go and I'm going to capture it. It's going to be just in there. So any X bar that I get, and remember, 95% of those blue guys are in this range. So any one of these X bars that I get, I'll create an interval that captures the true mean. Now, I don't have any idea where my X bar is. Sean Hahn thought he was right in the middle. He thought, man, I'm probably right in here. I'm good. And you're only doing this one time. That's all you know. Sorry. That's why that first assumption, simple random sample, is such a big deal. Right? If I'm standing outside of basketball practice getting heights, I'm probably going to get the X bar that's way out here, right? So I didn't give myself a chance. I want to make sure it was randomly chosen so I had just as equal likely a chance to be anywhere on the spectrum. Anything else? Okay. All right, so you've got one